Okay, who had the flash drive for the talks? Okay, there was a gentleman with long hair here earlier. All right.
I don't know if you.
No, this is, I have the flash drive. I would like to return it to the person who was asking for my slides. We'll just sit it up here.
Okay, I suppose it's supposed to be here.
We'll put it in the baggie.
Yeah.
All right.
Have a dance.
No problem. Those slides will probably make about as much sense as IKEA instructions without the actual presentation, but. Time to get started. Is it time to start, or shall we wait another minute for people straggling? All right. All right, good afternoon. Can everybody hear me all right? Okay. Generally, if I ask that question, people say no, it's probably because they have hearing problems. But all right, my name is Joe Brockmeier, and we are going to be doing kind of a team effort here. We want to give an update on Project Atomic. So, like to annoy people by making them raise their hands. This is, for many of you, maybe the only exercise you're going to get, except for, beer. So, how many of you actually know what Project Atomic is? All right, how many feel comfortable that if you were cornered in an elevator, you could explain it? Fewer. Okay. How many feel really weird about being cornered in an elevator? Okay. All right. My name is Joe Brockmeier. I work for Red Hat. Big surprise in this group, right? I work for the open source and standards team, and for the last couple of years, I've worked on Project Atomic. I also manage the community team. Also participate in Fedora and Centos a little bit. I have several co-presenters. What we are going to do is sort of a tag team thing. I'm going to give kind of a high-level overview of Project Atomic, talk about some of the components that go into it, a little bit of the background, and then I'm going to hand it off to Tomas, and he's going to give a deep dive into Docker, which I think many of you will be interested in, because it's easy to lose track of the new features that are slipping into Docker. So he's going to talk about some of the later releases of Docker and things that have come in there. And then I'm going to introduce Brian Exelbeard. He is going to give us a talk. He's going to give us a look into Nulecule, Atomic App, and the Atomic Developer Bundle. Okay. And then I'm going to introduce Steph Walter. He is going to give an overview of Cockpit. How many folks have heard of Cockpit? How many people have actually used it? Still a couple people? Okay. It is some nifty stuff, and if you haven't used it, by the end of his presentation, you're going to want to. And then finally, I am going to introduce and hand it over to Josh Burkus, who is our new community lead for Project Atomic. I'm very excited that he's here, as are we all. And he is going to talk about a little bit of his background, his view of Project Atomic and the container ecosystem, and where he wants to go with things. All right? So, all that is what I just said in written form. So, before we get started, if you can actually get on the Wi-Fi and get a decent signal, I like to encourage people to remind the rest of the world what they are missing. So I would encourage you all, through this presentation and all the rest of the weekend, to tweet about DevConf.cz if in fact you do have a Twitter account. If you don't, create one just so you can do this. And also follow, if you would like to keep up with Project Atomic, please follow at Project Atomic. I would like at the end of this talk to see at least 60 new followers, assuming you're not already following Project Atomic. And the conference Twitter is at DevConf_CZ, and the hashtag is hashtag DevConfCZ. And while I'm doing all this promotion of the social medias and things like that, I do want to very quickly give a shout out to the organizers of DevConf.cz. They have done an amazing job, as they continue to do every year. And so if you see one of the organizers walking around, please be sure to thank them for all the hard work they put in. Also, several Atomic talks have already happened, but I want to point out some of the other ones that are coming up. Right after this, Thomas Krall is going to do a talk on how you can use Nulecule and Atomic App. Tomorrow, Steph is going to do a much deeper dive into Cockpit and talk more in detail. We are also going to have a talk about using Fedora on Atomic for Internet of Things as kind of a, not as an Internet of Thing, but as a server to talk to Internet of Thing devices. Also, a interesting talk from Jan, Atomic with and without Atomic, and what that's talking about is doing development and using the Atomic command on non-Atomic hosts. Okay? I see somebody taking a picture. I'm going to hold that slide until he's done. All right, good. All right. And another one, more massively Atomic talks. We have Atomic Developer Bundle, Containerized Development Made Easy. Brian Exelbeard is doing tomorrow at 11:30. And A Graybeard's Worst Nightmare. I take exception to this title, but A Graybeard's Worst Nightmare, How Docker Containers Are Redefining the Linux OS. And that is 9 o'clock Saturday. So those of you who are willing to be awake at 9 o'clock Saturday can be entertained by Daniel Reek. Okay? All right. After all of that, do we all remember why we're here? We're going to talk about what Project Atomic is. Okay. I don't need to explain containers to anybody in the room, right? Anybody? Speak to me after class. Okay. So Project Atomic 101. It is the upstream community for developing the tools and patterns and so forth for developing Atomic hosts and generally the entire ecosystem around Atomic. That has expanded immensely since we launched Atomic in 2014. When Red Hat came out in April 2014. It seems so long ago now. When Red Hat came out with Atomic, we were still trying to figure out exactly what it was we were going to do with Atomic Host. We have a lot of ideas, but some of those ideas have already been chucked. For example, we were going to use GearD out of the OpenShift ecosystem, and instead, a couple months later, Google came out with Kubernetes, and we went, that looks good, and everybody's going to go in that direction. So let's work with Google, and that's been immensely successful. There are a lot of things over the last couple of years that have been changed, and the Atomic Developer Bundle was not a thing then. Nulecule and Atomic App were not a thing yet. So we have done a lot of work in the last 2 years or so. But basically, this is where we all come together to make this work happen. One thing that is not, and is important to remind people when they talk about Atomic, is that it is not a new Linux distribution. It is on purpose built out of components that we use for our other operating systems. So Fedora Atomic Host comes out of Fedora. CentOS Atomic Host comes out of CentOS. RHEL Atomic Host out of RHEL. The importance there is that we have a lot of folks using these things in the wild, CentOS, Fedora, and RHEL, and we want to make sure that Atomic fits into their ecosystem or their data center or whatever very easily, and so that they don't have to learn a bunch of new things on top of the new things they have to learn with containers and Kubernetes. So we want to make the transition easier. They get trusted software that's already been tested in other hosts, so that is very important. So why Atomic? We can already run containers on Fedora, CentOS, or whatever. The main thing is we want to provide an immutable infrastructure where people can run containers and not worry about the operating system below that layer. You should only care that Docker and Kubernetes and some of the other features, SE Linux, Systemd, those things are there to give you the features that you need to run containers successfully, but you shouldn't really care what version or anything else is going on under the hood. You should just worry that your containers will work, okay? That means not installing things on the host and treating your, I'm assuming everybody in the room is familiar with the pets versus cattle metaphor, okay? So we don't want people to treat the Atomic host as a pet. We want them to think of it as cattle, okay? Or some people object to the pets versus cattle metaphor, so in the US I use the Scotch versus PBR metaphor. If you have a bottle of really good Scotch, you care if somebody drops that bottle. If you have a PBR, you don't care. So if you don't like pets versus cattle, just replace that with Scotch and PBR. So what does Project Atomic include, or what does an Atomic host include? You have a question?
Yes. When you have the question, why Atomic or versus CoreOS?
What's that?
Do you have some comparison to CoreOS?
Do I have what now? CoreOS, yes, I'm aware of CoreOS, but
Will
what's...
you have some comparison?
I will not.
Okay.
So I figure that people can do, they're both open source more or less, so you can do your own comparison if you like. To be perfectly honest, I don't spend a lot of time watching what CoreOS is doing. I don't.
I thought that you can somehow sell that Atomic to
That's generally not my style. So I want to talk about what's good with Atomic, not so much like bash anybody else.
Okay.
So yeah, I'm sure that if you want to talk to somebody who will do that, if you find somebody who does sales, they'll help you out. I'm in the open source side. I actually like, I like the CoreOS guys, or at least some of them, the ones that I know, because we work together on things. That's what you do in open source. And we use a lot of components that come out of CoreOS. They use components that we work on. We both fight the good fight trying to get things into Docker. So yeah, I'm not going to spend a lot of time whacking them on the head.
Actually, you did some kind of conversion that you say that you use some of the features of implementation on Atomic and on CoreOS. Now you just say that
We use some of the same components, sure. We have used some stuff that they've come up with. So.
For me, that's enough.
Good, okay. So, some of the stuff that we have in Atomic. We've got rpm-ostree, which is sort of like Git for operating systems. I'll talk about that very briefly. Also, Colin gave a good talk earlier today, I believe, on that. Sadly, my TARDIS is broken, so I can't send you back to that talk. But I believe talks are being recorded, and if so, you'll be able to watch that. Atomic command, user bin atomic, which is sort of brainchild of Mr. Walsh back there, but now a cast of hundreds or thousands, or at least 10 people, have put patches into that one. There's Nulecule and Atomic app, and I'll let Brian describe those. Project Atomic, if you look on GitHub, we also have a repo for container best practices. We're trying to pull together documentation on what's the best thing to do when I am creating a container, because this is still greenfield for a lot of people. What is the best way that we should put together a container? You know, should I put everything in one container? Should I have a container for every service? Where do I do a volume store? Those things. We want to answer those questions. There is the Docker work that we do upstream. Under Project Atomic, you'll find an Atomic repository, a Docker repository that includes some of the things that we're trying to get upstreamed into Docker, which they may not have accepted yet. It'll also include the things they have accepted, but you may find some patches and interesting work going on there that hasn't made it through Docker yet. Kubernetes work upstream. We work very closely with those folks, especially on the OpenShift side, getting things into Kubernetes upstream. Atomic Developer Bundle stuff is hosted on GitHub under Project Atomic. I'm probably missing a few things. One question people have a lot is which one they should use. Should I use RHEL, Fedora, Centos? It depends on the pace that you want to move at, your tolerance for risk. So if you would like support, that makes the question very easy. You want to go to RHEL and you want to use your RHEL entitlements to run Atomic. If you would like to track what RHEL is doing, but you are not, you do not have RHEL entitlements, maybe you're just using it at home and don't want to pay for RHEL, or maybe your company doesn't subscribe to RHEL, whatever, then you want to follow Centos. They have a regular rebuild of the RHEL Atomic host. And then Fedora is where we do development and break things, try not to break things, but we try to move fast. And so we have a 2-week release that comes out of Fedora, and I'll talk about that in a little bit. So what do the Atomic hosts actually provide? It is a streamlined host. We try not to provide anything you do not need to run the containers on the host. We are trying to enforce the idea that if you want to run something, do it in the container. Even if it means system tools, figure out a way to do super privileged containers and put them on the host to do your debugging or whatever you need to do, and then pull them back off. We want the image to be as small as possible, and you will probably see a lot of work this year in trying to slim down that image. rpm-ostree, which provides the basis for shipping the image that you use. User bin Atomic, Docker, Kubernetes. I put an asterisk there because we are working on moving Kubernetes into a container, so you actually would not have Kubernetes shipped on the Atomic host. You would get a container with Kubernetes in it. But I don't think that we have finished that work just yet, so if I'm not mistaken, if you pull down the Fedora Atomic host image today, you will still get Kubernetes installed on that. So I'm going to talk very briefly about user bin Atomic. This is supposed to be kind of a coherent entry point to the system. So we want to make it easy to manage the system using Atomic and fill in some of the gaps in container implementations. And it also implements Atomic Run by looking at the label for a container. So if the person who created that container gave it a label with information to run the container, you don't have to tell somebody, well, to run this container, you need a string this long. You just do atomic run foo, and Atomic will look at that container and say, okay, I need to mount these volumes, I need to give it this privilege, whatever, and start it up, okay? The atomic host command can be used to do rpm-ostree updates. There are some new things since this time last year in Atomic, user bin Atomic. Migrate, you can actually move a container from one sort of storage to another, which can be very useful. Atomic scan, I put an asterisk by that because it's in Atomic, but it isn't entirely working yet. But when it is, it's a way to use OpenSCAP to look at a container and see how many CVEs it may have against it, which is very useful. So you can actually look at a container and go, okay, does my application, or do I need to update this because there is a gaping security hole in it, okay? Atomic top lets you see containers and the processes that are running in them. And then Atomic diff will allow you to compare two containers or images. So for example, if you have two containers that are the same, but you have somebody has added a couple of files to an image, you can see the difference between that and the stock image. And I see this gentleman raising his hand.
Yeah, quick question.
Sure.
Atomic migrate.
Yeah.
It migrates also the volumes I see there that are attached to the container?
I believe so. Dan, you want to answer that?
Yeah, Atomic Migrate is will allow you to say you're on device mapper and you want to try out backend RFS or
Overlay.
overlay, and allows you to go back and forth. Also, a lot of people start using containers as dev mapper on top of the back device, but if you want to go to production, we recommend you don't do that. So this gives you the opportunity to take all your containers and move it off, switch all your back end, so you can go from root back device to available device, virtual device. So that's what you get.
So, but all that is on the same host, not like
Yeah, this is not CRIU or anything like that.
Yeah.
Well, CRIU might be needed eventually, but yeah, we could, eventually we could do stuff with stuff together.
Okay.
Right now, it was just, the main focus was to allow you to switch it back in.
Gotcha. Alright, sure.
Did I see somebody else raising their hand? Or did that answer the same question? Okay. All right. And that's it for that slide. If you want to look into development there, you have a patch or a suggestion. It's just on Project Atomic/Atomic on GitHub. I want to talk about rpm-ostree very quickly. How many people have actually played with rpm-ostree at all? Not very many. Okay. It's really interesting. So basically, it gives you a read-only file system except for var and etc, where home and so forth is mapped under var. And etc will do a three-way merge when you do an update. So if you change the configuration of something, when you get newer stuff on the host, it's not going to just overwrite your configuration files, which would be a bad thing. But all the data, containers, and so forth are preserved on an update. But the nice thing about rpm-ostree is it allows you to switch between references. So for example, you can have an atomic host or a development system with, say, Fedora 23, and then you can have another one that's tracking Fedora 23 testing, and you can switch back and forth between those on the same host with the same containers and so forth. And it makes it very easy to do that. You can also roll back. So if you have done an update and something breaks, you can actually do a rollback to a previous known good version. And in fact, outside the container world, rpm-ostree came from ostree, which Colin Walters wrote originally to work for GNOME testing. So the idea is, I don't know how many of you have ever tried to compile GNOME from scratch, but it's not a lot of fun. And so he was trying to make a project go called GNOME Continuous that would allow developers to just follow a tree to do GNOME development, and they could switch back and forth between a stable system and a development system much more easily. Because we all know it's kind of a pain in the butt to maintain 2 or 3 systems to do your development. It's much nicer if you can just put it all on one laptop, right? Also, the Fedora workstation folks are actually looking at an atomic workstation right now, although I don't think they'll actually call it that in the end, that would use rpm-ostree for the base file system and then a different form of container for desktop apps. All right, so the atomic update model makes more sense for an immutable system. It still preserves the tooling, however. A lot of people, almost inevitably when I do a talk about atomic, there's somebody who wants to come talk to me about like NixOS or some other packaging format or whatever. It's like, all Red Hat needs to do is adopt this completely different packaging format and everything will be great. And it's like, except our customers will kill us, okay? The people who use all of these systems and have legacy things will show up with pitchforks and torches and they will be very, very unhappy. So this preserves the tooling that we have done around RPM. It preserves all the work that we've done there, but it makes it better, okay? Any questions on that? All right. Some of the new things recently in rpm-ostree, we now have rpm-ostree deploy, which makes it easier to move between specific updates rather than just saying, give me the latest. Colin is working on static deltas, making it easier so the updates over the wire are smaller. And also package layering, because one of the problems with rpm-ostree is that it is an immutable system, so you don't have the option of installing a package. Again, for the atomic model, for the atomic host server model, that's actually fine. That's kind of what we want. We don't want people installing things on the host willy-nilly. But there are other reasons why people might want to install RPMs. There's also the use case of installing RPMs to get hardware drivers or whatnot out to people where, you know, we may ship rel something, and somebody still needs to install InfiniBand drivers or whatever, something like that. I want to talk very briefly about some of the, it's interesting to work at Atomic because it's not a straightforward, we just push one thing, you know, push a bunch of stuff into the sausage grinder and then collect the sausage at the end. We work with a bunch of different groups to get the sausage. Maybe that's not the best metaphor for this, I'll work on that. But we have to do a lot of working with different groups because we need to, we committed to not creating a fourth distribution in the Red Hat family. We talked about that, and we decided what we should do is work through Fedora, work through Centos to get these things. And so the Fedora Cloud work group originally started well before Atomic was conceived or talked about. But over the last couple of years, Atomic has become the focus of the Cloud Work Group. We think that's kind of where the future is going. And so the Cloud Working Group has really focused on Atomic as the main thing that we want to push out. So since last year, I don't think we have these quite yet. We've added Vagrant images, which developers were begging us for that. So we've added those. The RelEng folks, the testing folks, everybody has come together. And Adam's back there salivating. He's like, yes.
I'm laughing at bullet point number 4.
Oh, okay. Yes, okay, fair enough. But the RelEng folks and everybody have been very helpful in letting it in getting this stuff out because another interesting thing about Atomic was that the Koji and other tools were not originally built to push out rpm-ostree images or trees. They were built to push out ISO images and then USB images and then AMIs. And so we have really made Dennis and some other folks work very hard to get things through. And they have risen to the occasion. And I'm very happy about all the folks who have come together on that. So we are now pushing out 2-week releases. We did 1 or 2 before Christmas. And we have consistently hit, I think we had a 1-day delay, but we've basically been hitting the 2-week deadlines. The idea is that every 2 weeks we look at the latest known good stuff and push it out the door. But there's always a possibility that we'll get close to the 2-week release and something in the chain will be broken. And luckily, so far nothing has broken so badly we haven't been able to get stuff out the door. And this gentleman has also been of great help there. So yes, more testing. I would love and just be excited beyond belief if everybody in this room would come in and do a little bit of help with atomic testing or testing anywhere in Fedora. Pick your favorite package, pick your favorite edition of Fedora, and participate. Download some of the testing images. Give feedback. Go to Bodhi and give test the latest RPMs and give +1s if they're not broken. Because the world needs much more testing so that Fedora can be as awesome as humanly possible. this is terrible blue text, so you can't read it, but this is cloud@listfedoraproject.org. So you can sign up there, and that list is, in general terms of mailing list traffic, is it's a little bit chatty, but it's not an avalanche of email. It's not as bad as Fedora Devel or LKML or any of those lists. And also, you can come find us in Pound, Fedora Cloud and IRC, and that's on Freenode. And we would love to see you if you would like to help with testing or have questions or whatever. And just for fun, I thought I would put in a diagram of our 2-week process, which is a little bit involved. And you can look at this in more detail later when you get the slides off of SlideShare or wherever we put them in the end, the DevConf website or whatever. But basically, the idea is that we build, test, and present. And we also had some good work from the Fedora design, the web team, yeah.
Ralph and I on Sunday are going to actually dive into how this works.
Okay.
In a presentation with somebody's.
Sorry, a little louder.
On Sunday, Ralph, Bean, and myself are going to dive into how that actually works if anyone's interested.
Okay, excellent. What's the name of your talk and when? Filled with confidence we are now.
Yeah.
Well, Ralph named it. I'm trying to find
All
the
right.
schedule.
State of Fedora Infrastructure 1040 D105.
There you go. And that will be a very interesting talk. And I say that seriously. The stuff that the infrastructure group and those folks in RelEng do to take something from source and walk it all the way out the door to a finished RPM or a finished image requires an amazing amount of work and coordination. And so you should definitely go to his talk. All right, I want to talk very briefly about the Centos Atomic SIG. So again, not creating a new distribution, working upstream or side stream or however you want to describe it. It's actually a very weird thing with CentOS right now because we can't really say they're an upstream or a downstream because what happens is we kind of do some of the work in Fedora and some of the work in RHEL right now, and then that eventually winds its way into a RHEL release, and then the source gets released, and then it goes over into CentOS. But we test some of that, and then things come back, and they go back into the other things. So it's a very weird circle of source. So anyway, right now we are pushing out monthly images. I believe a new image based on RHEL 7.2-ish came out like Monday or Tuesday of this week, and you can find it at cloudcentos.org, yada, 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 over here. If anybody can't find the image, just shout at me on Twitter. I'm just at JZB. I will find it for you and send you a link. Okay? But we do AMIs, we do ISO images, so you can do bare metal installs, QCows for those of you who would like to run this either with libvirt or on OpenStack. And we do Vagrant boxes there as well. New chair. So I started the SIG and worked with Jason Brooks and some other folks. But in the intervening time, Jason Brooks has really stepped up the work, and he's been spending a lot of time working with KB to make sure that these builds happen. Because CentOS Atomic Host is a little bit different than RHEL, than the standard images, and so there's usually some patching to Anaconda and things that need to happen for it to make it through CentOS okay. So he works to work with KB to make sure that we walk those patches through, test everything, and get the images built. So if you are using CentOS Atomic Host, give Jason Brooks a big hand. We do weekly meetings on Thursday at I think 1600 UTC. I need to get back to announcing those on a regular basis. Modulo travel and holidays, we didn't do any meetings over the holidays, the shutdown, and we haven't really been doing meetings because of FOSDEM and DevConf these last 2 weeks. We are planning to do 4-week releases out of CentOS, which will actually will be a little bit off of what they're releasing in RHEL. We want to get to the point where we're doing some testing of things a little closer to RHEL in the CentOS SIG. All right, that concludes my section in almost exactly at 30 minutes. I wanted to leave enough time for everybody else to do their demos and so forth. So now it is time for a Docker deep dive. So I'd like to introduce Tomas. Oh, and you have a question. All right, you have 57 seconds. 50.
Vagrant boxes.
Yes.
I pay for.
libvirt and VBox.
Thank you.
Yes. All right. And you need the
Yeah, I need the PC,
All right.
and I hope that HDMI will work.
What's that?
I would like to use HDMI because,
Oh, okay. I'll let you.
so I hope that it will work.
All right. Whatever you would like to do.
Okay, so give me a minute, please.
Okay.
This goes here, this goes there. And I need to.
Yeah, you should see it there once you're ready.
Yeah, it doesn't display anything. I know that.
Do you have just slides or do you have a demo?
Yeah, I have demo.
Okay.
So I know that this thing can be turned on and.
Yeah, it was working with mine, so.
Hmm.
Oh, does it need a different input because of the,
Yeah, exactly. So is there a thing to?
There's a stylus, and styluses make everything better.
Yeah, I don't think that's actually gonna be, all right. Here we go.
Yeah, it looks good.
Give us just a moment, folks. Sorry for the, I found a menu, but I don't see a,
Okay, so I go
Input.
for VGA.
It's not
Alright.
this box?
Yeah, but it says.
let's just do VGA.
Yeah.
Like this. There we go.
Yeah, that's better.
Alright.
Okay, so.
You all set?
Yeah, I think so.
Okay.
I just moved the. So hello everyone, I'm Tomas Tomecek and I would like to show you some cool new features in Docker Engine. The reason I'm doing this, as Joe already said, that it's really easy to lose track what's new in Docker because it releases every almost like 3 months and they put a lot of new features in there and for example I lost track badly and when I prepared this presentation I discovered all new features and I'm really excited about it. So okay, let's start. So first thing that I'm going to demo on Docker 1.10 which was released today actually, and I'm doing the demo on RC release because I haven't tried the whole demo with the final release because I don't want it to break, so I hope it will work. So RC, remember. The whole demo is open source. You can stop listening right now, put your headphones and go over it yourself. It's on GitHub. So I will show you the name of the, and that's probably more visible. So it's my space, Tomas Tomecek / DevConf 2016 Atomic Workshop. So if you run into some issues, just open issue or even open a pull request. So okay, let's start. So I will cover Docker 1.8, Docker 1.9 and Docker 1.10 and I will show only the most impactful features. I won't go over the whole changelog and show you that there is a new option for this command and that because that's like boring. So okay, let's start. So I'll use the GitHub for the as a slides and I will show you everything on the terminal. Okay, so let's move the terminal on the screen. Is it readable?
Is it possible to make it white background with,
Okay.
or maybe turn the lights off?
Let's try with the okay, colors. Yeah, so let's do fluorescent. Okay. Yeah, the thing is that I have all my shell tools optimized for Solarized, so if I do different scheme, it won't be usable. Sorry. Okay, so let's go to the slides and let's start. Here's some pre-demo stuff for me to actually run some containers in the background, so we can see some more interesting output. So let's start with Docker 1.8. The thing is that Docker 1.8 wasn't so there were not many features seen in front end because they were working mostly on back end. They've written tools for plugins, and they've also and they will also rewriting the backend. So to me the most impactful features were Docker copy and Docker daemon. So let's start with copy. So what this command does is that it allows you to copy files between your file system and containers and vice versa. You couldn't do this before because the only way to do this before this feature was to actually mount the container somewhere and copy the files yourself. But if your Docker engine was on different hosts, you had to actually SSH there and doing the process. So let's see how it works. So I will create a new container, this command. The container will be named banana. Yeah, it's after minions actually. There is already banana. So Docker remove. Yeah, I actually was trying the demo, so okay. So yeah, so right now it's running in the background. So we can try copy some files to it. So let's do Docker copy, and I'm in my GitHub repo, so I can copy, for example, license, which it's completing for container. So let's do copy license to banana, and let's copy it to the root folder. So it's done, and let's see. So Docker attach banana. So yeah, we are in our container, and if I do ls on the root system, we can see that license is actually in there, which is really nice. Right now I can actually copy it back, so I will split my terminal. So we are back in the GitHub repo, and I can do like remove license. So when I do git status, it says that I already removed the license. I can do Docker copy. So let's go from banana, and let's copy license, and let's copy it here. And that if I do git status again, you can see that license is really in there. You can also copy whole folders. The copy command actually doesn't have any options, it's just plain copy, so that's it. Let's move on. The other thing is that Docker changed the way how the Docker daemon or the Docker engine is running. Previously, it used to run with -d, and it was the option was available on the Docker root command. So now they created new command for that. And the reason why this is interesting is that all options for the daemon are actually moved to the daemon command. So if you used to go to man docker to get some to get information about options for daemon, they are no longer there. So I can show you that. Okay, so I will close this one, and I also close this one. So if I do man docker right now, it's actually showing man page for daemon. Interesting. Okay, so if I do docker help, it tells me all the commands and just the options for the whole Docker. And if I do docker daemon help, it tells me all the options for the daemon command actually. So this is really like this is a big change, because I've seen numerous issues for like, hey, you removed all the daemon options, are you insane? And no, they're just moved. Okay, so that's Docker 1.8. That one was released like half a year ago, and most recent release till yesterday was Docker 1.9. So let's go over that one. So the first thing that is really big there is the new command called network. So right now you are able to manage your networks. Before that, there was just one default bridge network which Docker created, and you couldn't do much about it. And right now you can actually create your own networks. You can write your own network drivers to have like multi-host networking and that kind of stuff. So with Docker there are just two drivers right now. There is the bridge driver, which is the way that Docker worked like till before, and there is an overlay driver which allows multi-host networking. But I'm not gonna demo that because it's really complicated. I mean, not really, but it's complicated to set up and it would take a lot of time, and in the end it would probably not work. So let's play with the bridge network. Let's play with the bridge networking. So, okay, so first let's see what networks are there. So I do Docker network ls, and I can see all my networks. So you can see there is the host network, which is the network you run if you don't want to use network namespace. So it won't create the whole IP TCP/IP stack, and it will actually run on your host network. Then there is no network if you don't want networking for your containers. There is the default bridge network, which Docker uses when you run some containers, and this is this is network I created. It's called Kiwi. Yeah, and this. Okay, so I'm going to create new network, and it will be named Fruits. So, and it will use the bridge driver. So let's see. So Docker network inspect fruits. Yeah, it's in there. So you can see it has its own subnet. It uses the bridge driver, and it has this ID. So whenever you need to identify it, it has unique ID, and of course the name I gave it. I think that the name is optional. Okay, so let's create some containers and add them to the network. So, okay, I have a networking image there. I'll show you that it really is there. So the whole build is cached. So it's image for my networking demo, and what the image is actually doing is that if I do vim networks dockerfile, it's really simple image. The only thing it does that it will run the HTTP server on port 8000. Yeah, and it also installs some networking tools, so we can do ping and IP and that kind of stuff. Okay, so it's built. Let's run it. So, okay, let's run the, yeah. So, yeah, when I was preparing for the demo, I forgot to remove the container. Sorry about that. And right now it will run. So yeah, serving HTTP on port 8000. Right, so I can't even clear. Okay, so I will split my terminal. Let's try that it works. So I do docker exec ty orange bash. So I'm going to inside the container, and I will try to contact the HTTP server. So I do curl xhead because we don't want all the stuff that all the HTML stuff, and we do, let's go here and port 8000. As you can see, it's working okay, really great, really easy, but it's not on the Fruits network. So let's connect it to the Fruits network. So right now we'll execute this command, which will actually take the container and put it into the Fruits network, so it's available within that IP range. So yeah, it's orange. Okay, I'm kind of lost.
You didn't start Pomelo.
Excuse me?
I don't think you started Pomelo. Pomelo doesn't exist.
Yeah, but this is orange, so yeah. I mean the first. Okay, so.
Yeah, you need to go back and start the Pomelo container.
Yeah. Okay. So. Okay. So I'll start another container, and I try to ping the orange container or access from the new container within the network. So. Okay. Yeah, alright, so it's already on that network, right? Now I see what... okay, so if I try to access the container, the previous one, it won't work because it's on the fruit network and this one is not there. So, yeah, but now I need to figure out the IP address of the first one. So, let's split this terminal, zoom it, and I do docker network inspect orange, no fruit, and there is this container running there. It's under this IP address. Okay, so we have the IP address, and now we can try the curl. So x head. So it's this IP address. Yeah, that's it. And obviously it won't work because they are not on the same network. So let's move the Pomelo container to the network fruits. Okay, so I will split my terminal and do this. So docker network. Okay, I'll copy it from here. Okay, so the container is in there. I'll close this terminal and now I try to do it again. And yeah, it's trying HTTPS probably, I guess. So if I do HTTP, okay, but it works apparently. So you can see that it's accessing. So yeah, this way you can pretty much run your services or your development setups on their own networks, and you don't need to worry about somewhat accessing your containers from space you don't want to. Okay, so that's networking. Any questions?
How comes that the zeros were working as a loopback in the curl?
I mean this one?
Yes.
Yeah, so you are accessing the all interfaces. I mean, yeah, all interfaces, and if any of them works, it will connect. So,
Okay, I didn't know that.
yeah, it's dirty trick. Okay, so that's networking. There are also multiple network drivers, not just the bridge and the overlay. The community already created more of them, so if you need some more sophisticated networking, it's available. Okay, let's move to volumes. Yeah, so previously there was no volume management, so you just created volume in dockerfile, or you mounted volume inside the container and it somewhat worked, but you couldn't manage it, you didn't know where it is and that kind of stuff. And now there's a proper volume management. So you can see what volumes there are, where they are located, you can remove them, you can create new, you can attach them to containers and that kind of stuff. This is very neat. Okay, so let's see. So I'm going to close this one, and I'll also close this one. So yeah, clear terminal. So docker volume ls. Yeah, I already have plenty of volumes because I play with the stuff a lot. These are probably generated by Docker, and this one was created by me. Okay, so let's create some volume. So yeah, I will create volume named Mango. It's there. So let's do Docker volume inspect Mango. Yeah, it's in there. The data are located in here, so I can go over there and look. I can run a container. So Fedora bash, and I can mount the Mango volume inside. So if I do v mango, and let's mount it at s/mango. So right now when I do ll mango, I can see that it works. I can even put some files in there, obviously, so some file is in there. And if I split my terminal and I will look into the file on my host system, I can access it, of course, because that would be like really insecure. Yeah, no aliases for sudo. Yeah, and the file is in there. What I kind of miss on volume, in volume command, is that you can't see what's inside the volumes through the API. So if I close this one, and if I again do inspect of the Mango volume, it doesn't say anything about the directory itself, like what kind of files is there, how much space they take, and that kind of stuff. And I can't even access them, so I need to create a container or something like that. But I guess that this will be improved in the future. Okay, so.
Sir, is there any support in dockerfile to create these volumes?
Yeah, well, you can use instruction volume, and yeah, it will create a volume. You can then see it in the list, but I guess that you can't name it, so it will be just the default ugly name. Yeah, and when creating volumes, you can actually specify a volume driver, so you can have the volume on like Gluster or something like that. So yeah, that's also configurable, and there are also plenty of volume plugins, so you don't have to have the directory stored on your host, so it can be somewhere. Okay, so yeah, build arguments. Build arguments are a really neat feature because they allow you to parameterize your build essentially. So you can change some arguments when building an image, and it will affect the build. So you can, for example, what Docker is saying in their documentation, you can specify proxy. So this will be available in your build, and then for another build you can put different proxy. The issue with that for me is that the content of the argument will be in the final image, so it will be in Docker history. So if you'd like to, I don't know, like specify some passwords or something like that via the arguments, they will leak in the final image, so it's not really secure. And there's actually an open issue for that, like that. Okay, so I specify my proxy and his name and password, and it can be seen in final image, and I don't want that, but the issue was closed. So I can show you that. So yeah, I will close the bottom terminal and run it. Okay, so let's see. So in my Docker file, I'll show it. Build args Docker file. There's a new instruction called arg, and the argument I name it fruit. That's the Docker file. And during build, I tell Docker that set variable fruit to watermelon, and it will exactly do that. So for the whole, for the build after the instruction, there's an environment variable available for the build, and it's named fruit, and the content of it is watermelon. So yeah, it's using cache. Okay, so let's do it without cache, so you can see actually the content. Okay, so now setting up the, registering the argument, and now you can see that the content of the variable was actually set. So this is a really neat way to pass some arguments during the build to your build process. So that's build args. Concurrent image pools. So if you've pulled image before, when you did pull in one terminal and did the same pull in another terminal, it used to say like it's already being pulled, or it even used to crash or something like that. And right now they completely rewritten that part. So when you pull image in one terminal and you do the same in another terminal, it will actually connect to Docker, and Docker will stream the progress even to the second terminal. So I can do docker pull project atomic app in this terminal, and if I do the same in here, it won't start new pull, but it will just stream the progress. So if I cancel the later one, it's still pulling. So I think that this is very nice improvement, and this was again rewritten in 1.10. So okay, so I'll kill it.
You just said it was reverted, so it's removed?
No, rewritten.
Rewritten.
Yeah. Yeah, so next thing is a new instruction in Dockerfile which is named stop signal. It's basically what it says. So you can tell Docker what way it should stop your container. So by default it's sending sigterm when you do Docker stop, and after 10 seconds if your application haven't been closed, then it sends a sig kill which wipes it completely. So you can tell Docker how to do that. I think that I'm sort of running out of time, so I will skip this because it's like really trivial, if you don't mind. And you can also set the signal for the stop when you are actually doing stop. So you can, if I do Docker stop help, you can actually set the signal. Okay, it's not here. So it's on run actually. Docker run help grab signal. Yeah, it's in here. So you can on run you can specify what signal it should stop your container. Okay, so DrStats. This is actually a really neat thing. You can see statistics of your containers. So yeah, I'm running several containers, as you could see in the introduction, and they have these resources used. This is actually done via 2 API calls. One API call is for listing all processes within your container, and the another API calls will send you the whole data about resources and that kind of stuff. So if you want to build an application on top of it, you can do it easily. Okay, so that's DrStats. And now we are at 1.10, which was, as I said, it was released today. For me, I think that was one of the biggest releases because they added so many code inside that it's almost impossible. They rewritten the whole backend, which means that the content of varlib Docker changed completely. I mean, it's the whole new thing, which means that when you upgrade to 1.10, it will take probably minutes to even start the Docker engine because it will need to reindex all the files and do the new layout. So it might be a good idea to actually, before upgrading to 1.10, to migrate the content of varlib Docker and then start the daemon. So that's their preferred solution. Or my preferred solution is to remove varlib Docker and start it over. Or move it so you don't have to do all that stuff. Okay, so they so the first thing in 1.10 is that they added seccomp to the Docker. So with 1.10, by default, all your containers will run with the default seccomp profile. Seccomp is a technology for disabling some syscalls in your container. So for example, you can deny doing read for all your containers with this, which obviously you don't want to do probably, but you can disable some syscalls which tend to have vulnerabilities, or if you want to deny some of your applications access to some more privileged syscalls. Okay, so I have prepared a simple demo for that. So let's see. I have created my new policy. I've created new policy, and I'm going to deny these three syscalls in my container. So it's get current working directory, change ownership, and change mode. So let's do that. Okay, so you can enable it with security opt, seccomp, and then path to the profile. And Docker has its own default profile where it disables some of the syscalls. And you can see it in this link. Okay, so let's start the container, and as you can see that it already is somewhat confused that it can do get CWD and that kind of stuff. For example, I can try to, if I do CVD, it's PVD. Okay, sorry. It even says that that the operation is not permitted. As I was showing you the policy, so there are multiple ways how to handle the process which is doing the syscall. I set it to deny, and there's also kill, so it can actually kill the process. And for the funs, I've created actually another policy, which I called hardcore policy, and it really denies the read. So if I try to run that container, it won't even start because it can't even read anything. Like I can show you the policy. Yeah, so you can disable read and you can't even start the container. But that's just for fun. Okay, so we are almost finishing up, and next thing is that in 1.10 user namespaces escape from experimental are not stable, so you can run your Docker daemon with user namespaces enabled. So user namespaces are the final namespaces which were not implemented in Docker, and they are now. And what they do is then they can map the users which are used within the container and outside of a host. So you can have root within container, which the container thinks that it's root, so you can install packages and do privilege operations. But on host, it's just different user. You will set the mapping in /etc sub UID. So for example, in here, Docker will create a new user which we'll call Docker remap, and it will have this UID on host, and within the container it will be root, but the root from host will act as this UID, so it's like messy a little bit. On Fedora, these files are not available like by default, so you need to create them yourself. That's what these two error messages are about, that Docker couldn't access those, so I need to create them. Okay, so the way you use user namespaces with Docker, that you run the daemon with this. So let's run it like it. Okay, so I have root shell in here. So here's my super long way to run Docker. So I've added user namespaces remap, and now I restart Docker. Yeah, I guess that it's trying to kill all my containers, and okay, so it's working. So now Docker is running with user namespaces, and let's try it. So I can do something like this. So I'm bind mounting my host file system inside the container, and it's available under /host. So if I do ll/host, yeah, it's really in there. You can see that it's under like different UID. That's my root from the host. And if I try to see the content of host etc shadow, which is my passwords, it's permission denied because it's different user, and without user namespaces this would also work actually, so I could see my shadow file. Okay, and we are almost finishing up, just 2 items, that's really quick. In 1.10 you can actually reload the configuration of your Docker daemon. You don't need to restart it, you just send sighub to Docker daemon, and so I'm not going to demo because the person who wrote the patch actually created this very nice GIF for that, so he's actually writing the config in here, and here is the Docker daemon which is running, and right now he just sends the command to it. No, right now he's about to send a sig hub to Docker daemon, and in here you will see that it just reloaded, and he didn't have to restart the whole Docker daemon. Unfortunately, it won't reload the whole configuration, but just some of the options, and you can read more. It's written in the it's in here. And the final thing is that Dan Walsh got accepted his patch for temporary FS, so you can actually create mount points within container which are temp FS. So and you can finally do full read-only containers, as he was saying during his talk. And you can read more about this in this blog post. Okay, so that's all from me. If you have any questions, I can answer it. And if you don't, I will pass my word to
You. Me. You.
Thank you, Thomas.
Well, I play the projector game. I'm Brian Exelbeard. I also have the privilege of working at Red Hat on Project Atomic, and I'm putting that here because it annoys me. And I work mostly on the ADB, but I'm not going to start out by talking about that. So, magic. Okay. I want to just briefly introduce the idea of Nulecule, Atomic App, and the Atomic Developer Bundle. I say briefly because there are talks on all of these things, and they're done by fantastic people, one of whom is me. So you should go see all of the talks that I'm setting up. Nulecule and Atomic App specifically are going to be talked about in this very room, in the very next session, in a workshop format. So I would strongly encourage you to go to Tomas's workshop. I'll be hanging in the back making noise because that's what I do. Very briefly, Nulecule is a specification for describing multi-container applications. All it is a specification. There is no magic here. There is just a whole lot of words in a spec, and they're lots of fun, and you can extend it. Atomic App, on the other hand, is an implementation of that specification. And so it is one of the ways that you can think about using this specification. It is currently the only way you can use the specification, but there can be more, and I challenge all of you to have more. So I'll just show you rather than tell you about this, and also I don't want to steal all of Tomas's thunder. Let's see here. You all can't see my screen. That's not good. Ah, there's the screen. And can I see my screen? No. Okay. Well, we'll worry about that later. So I'm not running Ash. I'm running Bash. So very briefly, let's talk a little about this. So you've got, let's just say, a single container application. Let's make this easy. You just want to run, say, Centos HTTPD because you need a web server and you really like the Apache test page. So we could all run Docker run, lots of fun stuff, -d, -p, blah, 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 blah. That's pretty easy. That's pretty basic. We're not doing that talk. But you want to try it out on Kubernetes. Kubernetes is an orchestrator. It's going to be awesome. You're going to be able to run HTTPD on Kubernetes and tell all of your friends. So Kubernetes has this concept of pods, which I will talk about very briefly in just a second, but I just want to prove there's nothing up my sleeve. I have no pods. I have no replication controllers, and I have no services. Well, I have one service because it's Kubernetes, but ignore that service. It is not here. So let's figure out how to do that. Well, theoretically, if I can remember how to do this, I can give it a name. We'll call it Beck's HTTPD. I'm going to use the image CentOS/HTTPD, and it's got port 80. Woohoo! Okay, I have a pod now. I can prove this to you by hitting up arrow a whole bunch of times. I have a pod. So what I have done is I have created a pod, which is a group of one or more containers that hang together in Kubernetes. It only has one friend, so there's only one container. And it's running on a Kubernetes cluster. It actually even is running. I used to have more minions than I have now, and they all went on vacation this morning, and I don't know where they went, so we only have one. And it also got a replication controller, which is going to make sure that that pod stays running. I want one copy. I get that stuff for free. Small problem. I can't actually get to this web page. It's running somewhere in the flannel overlay, and I can't get there from here. So I need a service. Well, this one command was pretty easy. I could figure out how to do this in Ansible, and I know nothing about Ansible. But I need a service in order to be able to get to it. That's basically something hanging on a routable IP that knows how to route back to this pod and get it. And so I went and said, well, I ran this kubectl thing, and there's no service option. So then I discovered that you have to build a piece of JSON. Here, I'll clear the screen and put it at the top. You have to define it in JSON. So this is defining a service called VexHTTPD, because I'm not creative, that's going to map a public port 8765 to the web service port 80. 8765 is also not creative because I copied and pasted this from Kubernetes.io. And that's because the preferred way of delivering this information, so if you all want it, is to copy and paste it. We didn't really like that idea. First we said, well, we could just put them in a zip file, but then like 1980 called and said it wanted its software distribution methodology back. Then we said, well, okay, we can take all this config data, we'll wrap it up in an RPM. And then Debian called and said, we'd really like to run your stuff, but we don't use RPM. And that wasn't very cool. And so we said, we have to come up with a way to do this that's going to make some sense. And we contained it. And what do I mean by that? So we came up with this nulecule specification and atomic app. And I'm going to fetch an atomic app. Actually, first, I'm going to show you awesome. So that's what it took for me to make one container in one pod with a service. And I could go bang on the service, but it's not terribly interesting. Oh, I didn't actually run the service, but we're short on time. So I ran the service. I'm going to actually pull one that I have already cached. It's very difficult to type like this. Centos 7 atomic app. Dun. Project Atomic, sorry. Can't spell. Lots of debug output, because debug output is awesome, and that's currently the default. But what I have done with one single command is I have launched lots of error messages. Oh, because the network here is not having a fun time with life. But the short version is I have 3 very broken pods. Normally they would not be very broken, but everybody's on the network. I could pull a Steve Jobs and tell you, if you don't cut off all of your devices, I'm not going to show you the iPad. So, anywho, the long and the short of it is, I was able to do that magically. How did that work? So with the atomic app, I will just fetch one so that you can see the whole magic of it. So I'm going to run it in mode fetch this time. And more debug output. But the important part is here. I can't get the mouse to the right place. That's the directory where all of the files landed by default in varlib atomic app. You can put them anywhere. I'm going to stick with the defaults. So varlib atomic app, and here I'll show you a secret. The one that I also ran, it's also there. So let's take a look at either of them because it doesn't really matter which one we look at. We'll use D because it's easier to type. Clear, find, dot. So this is what is actually in the atomic app. You're getting a README and a license. Those are fantastic. We know what those are. You're getting a Docker file because we're actually distributing the nulecule information and the atomic app executable for the nulecule in a container because we already have lots of fun tools to pass containers around the world and stick them in registries and validate them and build them and all kinds of good stuff. The Docker file is actually very simple. Literally, we are grabbing the pre-made container that has atomic app in it, and we are dropping the metadata in, and we're done here. So what is all this fancy pants metadata? And you will learn about fancy pants metadata in detail in the very next session, in this very room. But the short version is you get a nulecule file, which describes your application. This is GitLab when it runs. And it's a directed graph here that's telling you that you have to have a Redis, you have to have a PostgreSQL, you have to have the magical GitLab container down here. You can do cool stuff like have parameters, like here's GitLab's database information that it knows that it needs in order to get to Postgres, what port it should be on. Notice that there's this really wonky rule that says that ports are only allowed to be in a certain range, mostly to prove that you can have a rule that says that ports can only be in a certain range. But the idea is that you've got this configuration information. I want to draw your attention, though, to one thing up here.
I'm sorry, it's just all new to me. Is this something like Docker Compose file?
It's similar to the concepts behind Docker Compose in that it is allowing you to orchestrate, but this is, and you've set me up perfectly, allowing you to orchestrate on multiple different orchestrators with a single set of metadata. Here we've got orchestrator information for Kubernetes and for plain Docker Compose. And so we've got the information that you need. In this case, we've got a replication controller and a service file that's needed to launch the Postgres database, because that's actually the one we're at the bottom of right now. And we have the same thing for Docker. So we've packaged up how you run it, but separated from it some of the data about what you're trying to accomplish so that you can have a single process. The power of that is twofold, but I think this might show a little more interesting power, Docker PS. So I've got lots of things, and let's do this. I have, wow, nobody can read that because there's stuff. There's like 6 of them. So I can actually run one more of these real fast. Okay. But instead of running it on Kubernetes, I'm going to force the provider to be Docker. Lots of debug information. And now I have more of these things. And the reason for that is that with one command line option, I switched from one orchestrator to the other. So it gives you a little bit more power in that arena. Short version, and then I'll move back to the last 2 slides that I have, or 3 slides, is there's this answers conf that you can provide, and this is all the data that you need to make GitLab work in one single place. So if you just want to modify the data and then pick an orchestrator, it's very easy. The expanded version of all of this information in Tomas's talk. Don't think this is going to work, but let's see if it'll give me the slides back. Woohoo! Okay, so we had Nulecule, we had Atomic App, we're running out of time, so I talk fast. Yes?
One thing that I struggle always when I'm being presented with this is that the Atomic App, the binary, is not installed on your machine, so you would have it under control. That it apparently is packaged in that first container that you download. To download the software, to run the software, to download the software, sounds like when we were shipping exe file in attachments in there. Why is the implementation done this way and not by having Atomic App on the Atomic host, so that you would skip the first step of downloading binary.
I was not part of that decision, but my understanding of part of the rationale behind this decision is twofold. One, the Atomic host is supposed to be very minimal, so we're trying to minimize the number of things that we pre-package into it, hence the trying to get Kubernetes, for example, to be in a container. 2, you're always going to have to download something, because you've got to get the metadata at a minimum, and we're using a container to deliver that. And then 3, we are choosing to use the Atomic CLI as the entry point for all of these components. And so in this way, the fact that Atomic App is not on your host, the fact that you're not ever directly invoking it, really doesn't matter to you, because Atomic CLI took care of invoking the Atomic App to implement the Nulecule's requests. The other nice thing is that you could drop in an alternative implementation of Nulecule at the top of that Docker file and not have to worry about whether your implementation was installed across all of the various distributions and systems. I'd be happy to talk more about it afterwards, but I also want to leave some time for the folks who follow me. Okay.
Oh, yeah.
Very quickly, there is a library of these things. Please take a look at them. Please study them. Please send us PRs. The Atomic Developer Bundle will be talked about by Naveed, Sheikh, and I tomorrow. It's an easy-to-use container development environment. Very briefly, it's cross-platform. It is gives you a lot of ability with multiple orchestrators, and everything comes set up. We have 3 user cases we talk about: Command Line Carla, IDE Igor, and My Environment Mike. And I'd like to introduce you to those people with Naveed tomorrow. I'm done. Thank you very much. Complaints to @JZB.
Steph, do you want to just direct people to your talk, because we are down to 10 minutes?
Sure.
Or I'm sorry, or if you want to power through, it's up to you.
No, 10 minutes is, I mean, I'm sure someone else can make better use of the 10 minutes. So, Cockpit, we've been working on usability, and part of that is usability of atomic code, making it discoverable and usable, troubleshooting it. And so tomorrow we'll go into some of the information that we would have talked about here, which is, how it integrates with atomic codes, how we've been making OSTree better, how we've been figuring out how to containerize things, because everyone's trying to containerize stuff, but actually doing it you end up with a lot of troublesome issues. So if you're interested in those, and also CI, testing every day before merging thousands of times, instances of atomic codes with patches that people are submitting and all that. So if you're interested in that kind of stuff, come to the talk tomorrow. Or there's a hacklist, I think, in this area on Sunday, early, and we can go into more detail on those topics.
Thanks, and I'm sorry we did not have as much time as I was hoping. All right.
Is it just me?
It is just you.
Okay, because I'm gonna take 10 minutes. Bye. Howdy, I'm Josh Burkus. I've just started with the Atomic team at Red Hat as of about 2 weeks ago. And I'm just going to be talking to you a little bit about where we're going with all of this. So, like I said, I'm just Josh Burkus. And this is kind of a visionary statement. This is more of a personal vision. I joined Red Hat to work on Project Atomic because I already use containers for a lot of things. I'm involved with Docker, and I actually wanted a chance to work on container infrastructures full time. But most people actually know me for something else entirely, for PostgreSQL. How many people use PostgreSQL? 2 of them? Yeah. So I've been on the PostgreSQL. Oops. This is double clicking. I've been in the PostgreSQL core team for quite a while, since 2003. Started out actually a database developer with Microsoft SQL Server and Sybase. Been doing databases for 19 years. Been involved in a number of database startups, and forks of PostgreSQL and other things, and spending a lot of time doing consulting and building database-based applications in Silicon Valley. So how does a person like that get to Project Atomic? Well, one of the things that happened to me was interesting was a few years ago, actually this point 8 or 9 years ago, somebody introduced me to this concept of something called DevOps. And what DevOps, and when they finally actually explained what DevOps was and what a DevOps was supposed to do, I said, oh, so you mean more or less what I've been doing for the last 10 years. Because as a database administrator, database developer, for the longest time it was our job to make sure that applications went from development to production successfully. Now there's much larger infrastructures for that. But as a database guy, I still end up getting involved a lot in DevOps. And as somebody involved in a lot of DevOps, I was very interested in containers. And not just recently. I would actually say my story with containers starts in 1990. 1990, I helped pay for my degree in fine art, which is actually my university degree, by working in the University Computer Lab on VMS, on the large university VMS mainframe, which included a lot of administration of timeshares and who got what resources, because obviously everybody wanted computer time. And conceptually, this was sort of, as somebody actually mentioned earlier today, conceptually, this was more or less the same concept that we're dealing with containers in protoform. And so when FreeBSD added sort of jail support, because FreeBSD was one of the biggest platforms for Postgres in the early days, because they both came out of University of Berkeley, we immediately had support for FreeBSD jails for Postgres from the beta point. As a matter of fact, I was involved with what could arguably be called the first cloud web host, a company called Hub.org, which used FreeBSD jails to do multi-tenant hosting, something that nobody else really did at the time. So this continued until I went to work for Sun Microsystems in 2006, and was part of the Solaris department and was doing stuff with Solaris zones, including making PostgreSQL work well in Solaris zones. And this was one of the things I was really disappointed to lose when Sun got bought by Oracle and Open Solaris ceased to be a thing that anybody really cared about. Because there were a lot of really nice features in Solaris zones. So when I was introduced to Docker at version 0.5 in 2014, I got really excited about, hey, now I can have my zones back, but this time on Linux. But overall, what I'm saying is this is not a recent history, as in this concept of containerization or encapsulation is kind of fundamental to Unix and Linux in the first place. And the reason why it seems to work so well is it was always meant to be there. Now, one of the other questions somebody may ask is like, hey, if we had FreeBSD jails in 2000 and we had Solaris zones starting in 2005 and that sort of thing, why are those not all over the place now? Why did those not create the whole sort of ecosystem of things that Docker has? And one of the reasons for those is that those were basically kind of ops-only systems. As in, FreeBSD jails and Solaris zones provided a lot of things for system administrators and database administrators and a lot of tools for people on the ops staff to make life easier for them. But they provided really almost nothing for developers in the way of tools or advantages. And the result was that you had really good sort of system management platforms that were not used by developers to build anything. So they were there, they were great, nobody was building anything on them. And so they didn't take off the way that Docker has. Now, when Docker came out, the Docker team decided to do something interesting, which was instead of emphasizing ops, they would emphasize development entirely. The entire pitch is for developers is to make life easier for developers and to build easier development pipelines and develop on your Mac and all of these other things. And ops, someone else will take care of that. That'll be just somebody else's problem. Now, the result is that we've ended up with a tool chain in Docker, particularly if you're looking at like Docker 1.0 and that sort of thing, where it's great for developers, but ops people have a lot of problems with it in terms of actually deploying this. For example, I was at DockerCon 2 recently in San Francisco, and keynote, huge keynote, 1,500 people in the room. One of the Docker VPs is like, how many people here are using Docker? And 90% of the hands go up. How many people are using Docker in production? And 80% of the hands go down. And the reason for that is that the dedicated ops people, or even people who are not ops people but are just looking at operationalizing things, suddenly run into a whole bunch of problems and they start saying, maybe this isn't ready for us yet. Maybe we need to wait until this is a little bit more fully baked. So what we really need here is a little bit more balance between dev and ops. And that's actually what I'm excited about in joining the Project Atomic team. I mean, give an example where we actually need some more balance here. This is your sort of Docker, thing right here is our continuous integration vision, centered around Docker, develop, test, deploy, cycle, and that sort of thing, all around Docker containers. Problem is, for anybody who's actually done continuous integration in production, it's a little bit more complicated than that, because you don't just deploy, you know, you're deploying and then going back to development, but then you also have to maintain the old version because you've got a bunch of people who are on the old version and can easily be upgraded. Oh, and then you have upstream changes that come in either during the development phase and need to be tested, or come in and have to be patched against the maintenance version. And oh, don't forget that we have to actually secure all of this also. And then you've got those bug fixes that you find during maintenance or during development that have to be pushed upstream or to the development version of the application. So we really need something a little bit more sophisticated set of tools, a little bit more than just core Docker, in order to help you with this whole set of things. The whole real sort of application and deployment and production lifestyle. So because I'm a career ops guy, or a career de facto DevOps guy, I'm going to be looking a lot more, and what we're going to be looking at a lot more in the Project Atomic ecosystem tools and that sort of thing, is at adding a lot more sort of ops intelligence to what's already a great tool for devs. You know, so deploying reliably, maintaining versions and libraries, managing large infrastructures, ensuring availability, securing containers and images, persisting storage, which includes databases, because I am still a database guy. At least I'm going to be looking at that. But you've already heard from a lot of people, if you've gone to some of the other Atomic presentations, at this Atomic, about some of the tools that we already have to do a lot of these things. Things like, you know, orchestration, Kubernetes, Nucleo to help deploy reliably and consistently, rpm-ostree in order to make that atomic and reversible. Oh, and we haven't forgotten about the development people either. A lot of what we're doing for developers is more on the OpenShift side of things, with the integration of OpenShift, the idea that the promise of Docker is, hey, develop it on your laptop, deploy it into production, it's the same container. That hasn't been as much of a reality, certainly as I would like. We can make it a reality with Project Atomic and a lot of the tools that we have around them. So that's my vision. Thank you.
Okay. We are pretty much out of time, but I would encourage folks, if you have not already picked up on these, to check out these links and follow up with Project Atomic after the talk. Again, I'm really sorry we didn't get to have more time for Steph. I feel terrible that we did not get to fit his stuff in here. And we do not really have time for questions, but all the people that you saw speaking here today will be wandering around the halls. So thanks very much, folks. Sorry? Nobody said anything about that.
Yeah, well, you can do the notes for presentation.
Oh.
Actually,
You can leave them for the workshop too.
yeah.
Oh, okay.
It's up to you.
Yeah, I'll leave them for the workshop, because nobody told me we had anything to give out.
Yeah.
Okay.
Where are the stickers?
Oh.
Yeah.
Oh, thank you. Thank you very much. I will have it put on my laptop.
Yeah, we should have distributed those cards for the first people who ask questions.
Oh, okay.
Yeah, all right. I think I see one of the guys are asking me a question.
All right. Feel
I'll
free.
go scar people.
Thank you.
Okay,
Yes.
to run to my talk. So, so thanks for the. Yeah, it was really great, but I'm really sorry about Steph. I'm going to apologize because it was my fault. No, it was my fault.
I think tried to include too much in the talk, and so we
There's
shouldn't.
not enough time.
Yeah.
Okay, so see you later.
Okay. And I did copy, and somebody put it in a different bag.
Okay, perfect. No worries. Thank you.
Thank you.
I'm not sure whose laptop that one is.
That's the other guy who was speaking.
Oh.